This next topic is called conditional probability and some examples. So here's the definition of conditional probability. To find the probability of a dependent event, you can use conditional probability. The probability of event B occurring given that A has already occurred. Important. If A and B are dependent, then the probability of events occurring can be found by the following equation. So I want to talk first before we write the equation. What does these two things in the equation represent? The probability of A is the probability of event A occurring. So you take care of that first. Then, the next notation, how you say this little guy here, is probability of event B occurring given that A has already occurred. What we're going to do is we're going to multiply these two probabilities together. I think it'll make more sense when we get to our first example. So let's say we have a deck of cards. Event A is drawing a king first. Event B is drawing a king again. And there's going to be no replacement. So that means when we have a deck of cards, we pull a card out, we don't put it back in the deck. All right, so here is the steps. We first want to figure out what is the probability of A. So the probability of A, if you remember, is drawing a king. So someone gives you a card and you get a king. So think of how many kings are in the deck of 52. There are 4 kings out of 52. So now one king is gone. Now we want to find the probability of getting the second king. Now remember, we just took one card out of the deck. So now we're down to 51. And we took one king out of the deck. So now we're down to 3. So in order for us to find the probability of these two events occurring, to get a king and another king, we're going to multiply the two probabilities that we found above. So we're going to multiply 4 out of 52 and 3 out of 51. So 4 out of 52 is the probability of drawing that first king. And then 3 out of 51 is the probability of drawing the second king, knowing that we already got one king. So we're going to go ahead and multiply those two numbers together. So remember, when you multiply fractions, you always multiply across. So you get a 7 out of 2,652 chance. All right, let's do another example. You've probably seen this one before in my video. Marbles in a bag. We give you 2 blue marbles and 3 red marbles in a bag. So the first event, so event A, is drawing a blue marble first. And event B, conditional, is that you've already drawn that first blue marble, you want another blue marble. Again, no replacement. So once you take a marble out of the bag, you're not going to replace it back in. So here are the steps again. So the probability of getting your first blue is the probability of A. So we look up here, there are a total of 5 marbles in the bag, and there are 2 blue marbles. So that's the first probability, getting that first marble as a blue. Now we've just taken a 1 blue marble out. So what is the probability of getting a second blue marble? So we say, what is probability? We already have 1 gone. So now we have 4 marbles left. And how many blue marbles do we have left? We only have 1 left. So the probability of getting a blue and another blue marble, probability of A, getting that first marble, times the probability of getting another blue marble that we already got 1. So go ahead and multiply across. 2 out of 20, and reduce it to 1/10. I did put up here a picture of a tree diagram. You've seen this before, so here is the beginning. Probability of getting A is 2/5. 1 is gone. Probability of getting a blue again. We multiply these two numbers together, and we get 1 out of 10 chances. All right, here's our last example of conditional probability. So let's imagine we have two dice. One of the dice is a white dice, and one of the dice is a red. And this is a straight 1 to 6 numbers on the dices. Event A, the probability of getting a white cube that shows a 6. And event B is we're going to say that we got a 6 on the first roll. Now we roll the other one. What is the probability that when you roll the two dice, that the red cube shows a sum of two cubes greater than 9? So, to help you out a little bit, I put the sample space of our rolling dice out here. So if you look at the sample space, this is for it could be used as for the sum. So let's talk about the probability of A. What is the probability of getting a 6? So if you think about how many numbers are on a white cube, there are 6 different choices, and if you want to get a 6, you have a 1 in 6 chance of rolling a 6. Now, I'm going to go ahead and remove all of the white 6s, okay? Because we've already chosen that. Now we're going to go ahead and find the sum greater than 9 with the red cube. So again, all the white ones are gone. All the white 6s, I removed them. So let's go down to the sample space and see which ones are greater than 9. Well, this one sums to 11. This one sums to 10. This one sums to 10. So we have 3 left. And we have how many total here? 1, 2, 3. So we have 6 here. We have 6 here, 6 here, 6 here, 6 there, right? And then we removed 1 dice already. So we have 3 out of 30. And now we multiply these across. So 1 times 6, 3 out of 30. Reduce. So you have a 1 out of 60 chance of getting a sum greater than